Welcome to doassignment-ca. Here is the problem. Solve each equation and classify the result. Part A, 4 times the quantity x plus 2 equals 4x minus 6. Part B, 3 times the quantity 2y minus 1 equals 6y minus 3. Part C, 5z plus 10 equals 5 times the quantity z plus 3. Explain what each result means about the number of solutions. Now let us work through the solution step by step. Before we start solving, let's review the 3 possible outcomes for any linear equation. First, we might get one specific answer, like x equals some number. Second, we might get a false statement, something like 8 equals negative 6, which means there is no solution at all. Third, we might get a true statement like negative 3 equals negative 3, which means every real number is a solution. We call that an identity. Keep these 3 cases in mind as we work through each part. Let's work on part A. The equation is 4 times the quantity x plus 2 equals 4x minus 6. We distribute the 4 across the parentheses on the left side. 4 times x gives 4x, and 4 times 2 gives 8. So the left side becomes 4x plus 8, and the right side stays 4x minus 6. Now subtract 4x from both sides. On the left, 4x minus 4x cancels, leaving just 8. On the right, 4x minus 4x cancels too, leaving just negative 6. We're left with 8 equals negative 6. That is always false. No matter what x is, 8 will never equal negative 6. Because we ended up with a false statement, part A has no solution. We write this using the empty set symbol. Thinking graphically, the left side and right side are like 2 parallel lines, same slope but different intercepts, so they never cross. Moving on to part B. The equation is 3 times the quantity 2y minus 1 equals 6y minus 3. Distribute the 3 on the left. 3 times 2y is 6y, and 3 times negative 1 is negative 3. So the left side becomes 6y minus 3, the right side is already 6y minus 3. Both sides look identical. Subtract 6y from both sides. The 6y terms cancel on both sides, leaving negative 3 equals negative 3. That is always true, no matter what value y takes. Because we got a statement that is always true, part B is an identity. The solution set is all real numbers. Any value of y you plug in will make the equation true. Graphically, both sides represent the exact same line, so every point is an intersection. Now part C. The equation is 5z plus 10 equals 5 times the quantity z plus 3. This time we distribute on the right side. 5 times z is 5z, and 5 times 3 is 15. So the right side becomes 5z plus 15. Subtract 5z from both sides. The z terms cancel, leaving 10 equals 15. That is always false. 10 and 15 are different numbers, and no value of z can make them equal. Because 10 equals 15 is false, part C also has no solution. The equation is a contradiction, and the solution set is empty. Here is a summary table for all 3 parts. Part A gave us 8 equals negative 6, which is false, so no solution. Part B gave us negative 3 equals negative 3, which is true, so all real numbers are solutions. Part C gave us 10 equals 15, which is false, so again no solution. The key rule to remember: if the variable disappears and you get a false statement, there is no solution. If the variable disappears and you get a true statement, every real number is a solution. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.